Rock some more math? I think so. Okay, so reviewing multiplying special cases. Remember, they are called special cases only because they look different in the beginning or maybe sometimes at the end. So for problems like this where it has a binomial, remember our two terms, being squared. To square something means to multiply by itself, so you would always rewrite 4x squared minus 3y. So there's the binomial, and now we square it, which means multiply by itself. All right, there we go. Now do your FOIL or box method. So we would have 16x to the fourth minus 12x squared y minus 12x squared y, and then plus 9y squared. Simplify, which means combine only those that have the same combination of variables and exponents, which would be your middle two. They're both negative, so you add them, keep the sign negative, and there's your final answer. Now for problems like this one, where you'll notice these first two terms are exactly the same, the second two are the same except for those opposite signs. So what happens is your middle two terms end up canceling out. So when you FOIL, you'll end up with 25y squared minus 10xy, and then plus 10xy, and minus 4x squared. So these will actually take care of one another and become a 0. So you end up with 25y squared, minus 4x squared. Pretty cool. All right. So now we're moving into factoring. And this is a special type of factoring, well, a special way of doing factoring, which is factoring by grouping. Okay, so remember when we used the GCF to factor back in, I think, the second section, where we would take the greatest common factor out? Well, this is similar. We're still using the GCF, but we are going backwards. Right? So now you're thinking, what in the world? What are you talking about, Mr. Fontes? You're crazy. Well, I am, but I do know what I'm talking about. So, first of all, you use FOIL to multiply two binomials, right? So we do our first, our outer. So first, outer, inner, last, right? And then we simplify. So this would be your final solution. Well, now we're doing something, and this is a term that I made up. All right, anti-FOIL. I made that up when I was making this. That's not real. So anti-FOIL method, which is factoring, which means we're, instead of going from the blue to the purple like this, we're reversing that, and we're going from the purple to the blue. So we are taking the polynomial, splitting it up so that we have the product of two binomials. This is crazy. Crazy, right? Oh no, overwhelming. Let me fix this. Okay, first of all, we're only using polynomials with 4 terms. Okay, it's very important to remember because there's a little bit different way to do this, a different way to factor when we get into those other sections. 4 terms is what we're dealing with right now. Here's the example we're going to work. N to the third minus 12n squared plus 2n minus 8. All right, first, use parentheses to group to get terms and the last 2 terms. Okay, so there's 4 terms, so that would mean your first 2, you want to group together those, and then your last 2, you would like to group those together. Now what's very important with this is that you put an addition sign between the sets of parentheses. Okay, so what I'm here, I just rewrote the problem, added in the red parentheses, and added the addition sign in between. If you do not put an addition sign, it will look like this. It will be 3n to the third minus 12n squared, and then directly next to it you'd have 2n minus 8. Well, guess what? You just turned a problem into multiplication that is not any multiplication here. There's no multiplication. All right, so remember that addition sign. Once you've done that, you're going to find the greatest common factor of each set of parentheses, take it out. So here, greatest common factor, 3n squared, and then for our second set, 2. What's really important is that the binomials that you have left over should be exactly identical. Okay, if they're not, then you found a factor, so something they had in common, but not the biggest number or biggest term that they have in common. Okay, so as a For instance, let's say you only took out 3n and not 3n squared. Well, then you would end up with n squared minus 12n. And if you took the 2 out of the other one, all right, so remember this I'm giving you an example of right here, okay? If you look at this n squared minus 12n is not the same here. However, if we were to take another n out to make that 3n squared and drop these all down, then, oops, I just realized that I'm a dum-dum, and that's actually supposed to be a 4. Man, why didn't you say something to me? Goodness. Huh. All right, there we go. Fixed. All right, so now we have n minus 4, and then plus 2 times the quantity n minus 4. All right? And then I realize also I'm not so brilliant a second time. All right, so now that it is really actually fixed, in the white, I did not take out the GCF, and the term left in the parentheses are not identical. Once I took out the GCF, ta-da, they're identical. Okay, now this part is just a repeat, okay? So don't recopy. There's no need to recopy this. You already have it. I'm just putting it here so it's all on one slide together. So your third step, you want to group the GCFs. So put the red terms, 3n squared, and then a positive 2 in one set of parentheses. And then directly next to that, write what was left over, the n minus 4. So there we have our factored form. And then you can check it using your box or FOIL method, whichever you feel more comfortable with. Okay, so let's go ahead and use it. Oh no, I lied. Let's not use it. Let's talk about why it works, because I know you're looking, and you're looking a lot like this guy, right? You're like, what? What is happening? I don't understand. I'm so confused. Why don't we write this twice in here? Because there's 2 of them. Well, let me tell you why. So we all know that the FOIL and box method is really just a fancy distributive property, right? Okay, so it's just fancy, it's still distributive. So here's the thing. If we were to start with our 3n squared plus 2, and then multiply that by n minus 4, if we use the FOIL or the box method, here's what we're actually doing, is we are taking this 3n squared and making sure that it gets multiplied by both terms in the second set of parentheses. So really, we're taking that 3n squared and multiplying it by both terms, right? If you use the distributive property with this problem, that's what would happen. And then we're taking this 2 right here and distributing that to both terms, right? So then we have plus 2 times n minus 4. And if you'll look, does that not look exactly like our second step? Oh, this is amazing! Da, 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 da. So let's do this. All right. So, yeah, that's right. I put lasso this one in. Yeah, that happened. Step 1. What? Is to group together first 2 and last 2 plus sign in between. So this right here would be the division of your first 2 and last 2. Remember that this minus sign sticks with the 2m squared. So we have 8m to the 5th plus 12m to the 3rd. All right, now we put a plus sign in between and then rewrite our second terms. And remember, the reason we can write this plus sign right here is because plus a negative means subtraction. Okay, those are exactly the same thing. They have the exact same meaning. All right, then we move on to step 2. Step 2 was to take out the GCF, right? So what do these have in common? Well, first of all, look at your variables. They each have m to the 3rd, right? Now, as far as the numbers go, the coefficients, they are both divisible by 4. So when we divide 8 by 4, you get 2. M to the 5th divided by m to the 3rd, you get m squared, plus 12 divided by 4 would give you 3. M to the 3rd divided by m to the third would give you 1, which we don't need to write times 1, so we're done. Okay, now look at these two. They don't have variables in common, right? And neither of them have a common factor. So you're probably thinking, well then the greatest common factor is 0. No, that's silly. Of course it's not. The greatest common factor is 1. 1 is the only thing you can take out. Okay, so remember in that second step, it said to make sure that the set of parentheses were identical. Are these identical? And I really hope that you just answered no. Okay, so 4m cubed, and then 2m squared plus 3. Now here's what you'll notice. Our term right here is a positive 2m squared. This is negative. This is a positive 3. This is negative. So if you took a negative 1 out instead of a positive 1, it would change the signs of everything in the parentheses, and they would become positive. Well, how about that? Now they're identical, right? 2m squared plus 3 and 2m squared plus 3. The last step, our third, so step 3, group together your GCFs, so 4m to the third minus 1. Directly next to it is where you will group together what was left over, 2m squared plus 3. How about that? Is that not absolutely amazing? Yes, it is. Now your last step, check it. Start with your foiling. 8m to the fifth, so first terms. Outer terms, a positive 12m to the third. Inner terms, negative 2m squared. And last, negative 3. Does that match our original problem? Oh yeah, definitely. We are rocking. All right, we've got it, right? We got this. This is easy. Let's keep going. Now check this one out. Step 1. All right, what was our first step? Grouping. So remember, first two, last two. So we group together 15q to the third plus 40q squared, plus sign in between, and then last two terms. I don't know what that was writing right there. So 3q plus 8. All right, step 2. GCFs. Well, they each have q squared in common, so I'm going to take that out. What are they both divisible by? Let's see here. Perhaps it's 5? Of course it's 5. All right, 15 divided by 5, 3. Q to the third divided by q squared is q. 40 divided by 5 is 8. Q squared divided by q squared is 1, so we're not going to write times 1 because that's just silly business. Okay, now, do these both have a variable in common? No. Do they have any coefficient in common where we could divide both of them by something? No. So that means 1 is their greatest common factor. So there we go. That's all they have in common. And now check this out. Look at this. They are identical, right? Isn't that crazy? So now in our third step, group them together. Take your GCFs first. So 5q squared plus 1. And then group together what was left over, 3q plus 8. And then your last step, check it by foiling. First terms, 15q to the third. Outer is 40q squared. Inner, 3q. And last, 8. Isn't that just absolutely mind-blowing? And look, now you're all smarter, right? Your brains are just bursting out of your head. You can't even hold all this knowledge anymore. So here are the steps again. Group first two, last two. Make sure you put an addition sign between the sets, very important. Factor the GCF out. Group the GCFs in one set, the leftovers in the other set of parentheses, and then check your answer. All there is to it. One thing I want you to is that the GCF won't, it's kind of coincidental that in this problem here, the GCF was a -1, and this problem, my second problem, it was a +1. Okay, that is coincidental. It will not always be that way, especially if you look back at the very first problem we did. Their GCF here, we had 2 and 3 unsquared. Okay, so if they have nothing in common, and you know what, I'm going to make you write that down because that is important. Okay, add this to the end of your notes. If the terms have nothing in common, their GCF is 1. All right, well, I hope you're ready to just keep on keeping on.